Next piece is parallel perpendicular. So for parallel, those lines are lines that never touch, and what's special about them is they have the same slope. So same m. So for an example, y equals 2x plus 7 and y equals 2x minus 9 would be parallel because they have the same slope. Perpendicular lines are our other special case, but they cross each other at a 90-degree angle. So their slopes are what we call flipped and opposite. So for an example, y equals 1/2 x minus 3 and y equals negative 2x plus 4 would be opposites because 1/2 and negative 2 are flipped and opposite. Opposite is that one is positive and negative, and the flipped means you're flipping the fraction. So you're switching the numerator and the denominator. Last little piece is we want to practice writing parallel and perpendicular lines. So we're going to be working with this equation. First off, let's indicate our slope, which is the number next to x. So it's -5. We want to write an equation that is parallel, so the slope is going to stay the same, to the given equation that goes through the point 3, 6. So we know its slope is going to be -5 and it's going to go through the point 3, 6. I'm looking at this and I'm seeing point slope form. I have a point and I have a slope, which means point slope form is excellent for this. So we can write y minus y1 equals m times x minus x1. M is right here, -5. Our x1 and our y1 we're going to get from this point. This would be x1 and y1. So x1 would be 3, and over here our y1 would be 6. Now, if they wanted in slope-intercept form, all we would have to do is convert like before. You distribute the -5. So we would have y minus 6 equals -5x plus 15. And then we would just need to get y by itself, so add 6 to both sides. And we do y equals -5x plus 21. These two equations are exactly the same. They're just in different forms. They would graph the same line. If you don't believe me, open up Desmos on your Chromebook, go to that website, type in both of these equations, and you will see that they are the same graph. All right, last example is we want to do the same thing, but we want this line now to be perpendicular to the given equation, so perpendicular to this equation. So our original slope was -5, write that as a fraction. We want to flip it so it becomes 1/5 and make it the opposite. This is negative, so this one's going to be positive. So this is the slope we're going to be working with, 1/5. And it goes through the point 10, -7. So again, I'm looking at the information I have. I have a point, I have a slope, which means point slope form is going to be the best way to write this equation. So we set up the generic version of point slope form, y minus y1 equals m times x minus x1. Plug in the given information, y minus y1 that we get from the point, which is -7, equals m, 1/5. Remember, we're using this new slope right there. And then x minus x1, which is 10. Make sure we change this double negative to a positive, and there we have our equation. Again, if the was requested that we put it in slope-intercept form, all we would have to do is again do that distribution. So we'd have y plus 7 equals 1/5 x, and then 1/5 times -10 would be -2. And then we just have to get y by itself by doing -7 on both sides. We get y equals 1/5 x minus 9. Again, if you want to check, these two equations would be the exact same line when graphed. And they would both be perpendicular to our given equation right up there at the top. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.